basically, this is a webinar from the UK and Ireland Spill Association from the Plastic Pollution Working Group. It's kindly sponsored by OAMPS, who are our event sponsor, and enable us to hold these events. So I'm grateful for them. So we're basically UK and Ireland Spill Association is the trade body for marine and inland response companies in the United Kingdom, and we represent contractors, manufacturers, and consultants. And alongside this body, we have International Spill Accreditation Scheme, which runs inland oil and chemical spill training, as well as accreditation for those involved in inland spill response. Plus, we also provide accreditation for the Maritime and Coast Guard Agency scheme for the accreditation of marine spill response organizations. There is quite a lot of noise in the background, so if you could make sure that you are on mute. I think most people are, but there is a bit of noise in the background. If we can watch that, it will enable everyone to hear what we're saying. So the Plastic Pollution Working Group was formed in 2020 to support local authorities who in the United Kingdom have responsibility for the shoreline within their area of management. There'd been a number of incidents on the northwest and on the northwest and northeast coasts of England, where there had been plastic pollution spills, and frankly, the response wasn't adequate. And the Environment Agency asked our association to develop a nationwide spill response plan, which we did. But as soon as we started engaging with our members on this, we realized there's a lot more to it, and there's a bigger problem to solve, and our mission grew, as you'll see. So what we did is we grew into a multidisciplinary group of member companies, regulators, academia, and I suspect that our group will continue to grow. Now, when the MV Express Pearl incident occurred off Sri Lanka in May 2021, it involved a number of our group's members. And this is the most recent incident where there was a significant spill of nurdles with awful consequences for marine life, shoreline, the local environment, and of course the local fishery, on which a lot of employment depends, and a lot of protein is fished to feed the population. Now, there is still a lot of learning coming from this, and other recent incidents like the MSC Zoe, which lost 345 containers in January 2019, of which the contents of several of these containers impacted the Wadden Islands, with many sinking, but the remainder also impacted the Danish and German shores, and there have been other incidents since which members have dealt with. Consequently, with live learning and the experience building from MV Express Pearl, the group decided that we would share what we learned by collaborative production of a series of best practice guidance documents and webinars, which are in the form of papers, and webinars, and of which this is one. And the group committed to a series of goals to be completed by the end of Q1 2023. And you can obviously see there's some slippage on that. So we agreed to focus our work on microplastics initially, and the European Maritime Strategic Framework Directive defined microplastics as plastics with a diameter of less than 5 millimeters. And it is used as a standard measure in the analysis of marine and freshwater systems. So these are some of the goals. The ones in italics are goals that we've delivered. And you can see here the member companies, and we're very grateful for their support. In fact, ISCO is also, sorry, there you are, ISCO is a member. And the one in red is what we're going to be talking about today. Now, all of the goals can be seen on our website, and you'll see the link later on in the presentation. And our website is www.ukeirespill.org, and you'll find in working groups one called Plastic Pollution Working Group, and you'll find the details of what we're doing there. So this webinar is covering this. effective approaches for surveillance and modeling of macro and microplastic to aid response efforts, prediction of plastic movements, and source identification. Now, I'm very fortunate in being joined by Kate Brown from Oil Spill Response. Kate is a specialist modeling person, and she has a degree in that, and she's brought into the modeling and predictive team within Oil Spill Response, and she'll be delivering the session within this talk on modeling. Now, if I could ask for questions at the end, or better, put them into chat and I can hoover them up as we conclude this presentation. So we're going to cover remote sensing, innovative technology, modeling, citizen science, data sharing, identification of sources, and stakeholder engagement. Now, satellites. Everyone thinks satellites are the solution to all our problems. And indeed, I would say in part they are. But there are certain limitations. Now, on a clear day, a plastic cluster of 50 square meters would be detectable from space using an optical satellite. Small clusters of plastic nurdles, such as the slow release from a sunken container or the outfall from a plastic manufacturing plant, are unlikely to be identified. Satellites are able to be passive observers, but when supported by algorithms and artificial intelligence, enable passive observation to become active monitoring. AI identifies a difference between a prior observation and the current observation, and then notifies an analyst to investigate the difference. And AI will identify and what the AI will do was flag up to the monitoring company. Now, the monitoring company will then find pixels in the image of the water that have a higher reflectivity in the IR part of the spectrum, of the light spectrum. And it is that which shows the non-conformance that you're seeking. It is quite a science, and I would say it's come a long way in the last 3 years, but there is longer to go. And a lot depends upon the resolution of the image that the satellite delivers, be that a radar image, or be that an optical image, or be that an infrared image. There's a lot can be affected in the quality of that image in the conditions on the ground. For example, an optical satellite is obviously not going to see much on a cloudy day. An infrared satellite is not going to see a lot when there is a dust storm, for example. It's just going to see what the infrared, which is in that sand storm, as opposed to what's on the ground. So it does require the analyst who will have to be trained in what they're seeking to find, such that they can get the best out of the images that are available. But satellites are a fantastic resource, and certainly they are, they really do aid the spill response effort. Now, a good example of this was in August 2022, following a collision between OS-35 and Adam, which was a liquid natural gas tanker. OS-35 was beached, and this is an image of it here. The portage of this, and there you can see on the slide a picture of where it was and its proximity to the Rock of Gibraltar, which is just to one side of it. So the Port of Gibraltar closed. There was likely to be an impact to the Spanish coastline, but tracking was absolutely essential to provide a perspective on the scale of the incident, so that the Port of Gibraltar, which is both a commercial port, but also a military port, but also the access into Gibraltar Bay, which then where there is a Spanish port, people need to know what they could and couldn't do. OS-35 had fuel on board, and that was obviously a significant concern. Now, this is an image which Orbital EOS has been kind enough to send to us. And the little blue spot in the cluster of red shows where OS-35 is sat, and you can just see the picture of her. Now the issue was, and you can see how close she was to the Rock of Gibraltar, and you can see the port on the Gibraltar port on the other side of the rock, and you can see Gibraltar Bay, and you can see where the other shipping is in that bay. Now, what you can also notice is through their analysis, which I think is called EOS Viewer, you can see the level of detail which they're able to extract from this image using their analytical tools. It shows you the thickness of the oil, the likely quantities of the oil. I mean, it's really impressive what you can get. But of course, this would be an image, an optical image on a relatively clear day, but obviously they've overlaid onto that some of the infrared image to give some of the other differentiation in the quantities of fuel which are there. So it's fantastic what satellites can do. And if you were to run a sequence of these, you will then see how the fuel dispersed away from the vessel until it was starting to be contained by the responders. But it's this sort of information which enables, if you like, the incident command, in this case, the port of Gibraltar, to manage their operations in that port, but also to manage with the spill responders how they were going to manage the incident and make decisions going forward about how they could operate the port, operate access into the Bay of Gibraltar to make sure that the spill was not being unnecessarily spread. So this is a good example of how satellite imagery can inform decision making and be part of a predictive tool. Now, the other thing which satellites can do, satellites can flag up a problem, but they may not be able to look at the detail of the problem. But this is where drones come in. Drones, the advantage of drones is they generally have they have a long endurance. They're easy to mobilize. They can have a wide operating range, and they're ideal for monitoring a maritime region. They're able to sit above an incident and assist the response operation. They can operate day or night, and they can operate in a wide range of environmental conditions, primarily because they don't rely on a human sat inside this aerial vehicle to run it and to monitor it. It's being run from the shore. And in fact, you know, we've all learned a huge amount about the capability of drones through the regrettable war in Ukraine. But it has pushed drone technology on significantly and revealed the capability which drones have. Now, the one in this picture is a drone which is operated on behalf of EMSA. Now they have a drone which sits and monitors vessels coming in and out of the Mediterranean through the Straits of Gibraltar, which actually is out there looking for harmful emissions coming from vessels, but of course it's able to be retasked to do other things. The beauty about drones is they can have a variety of sensors mounted on them, which could be mission specific. It also carries a responder, so it's identifiable to other aviation, but it's also visible to mission command. And of course, it's remotely operated, and the incident commander can direct where it wants it to look to find out to find out how the plume is developing and where the plume is heading, and in between satellite images, which will also provide that that information. So these are fantastic tools, and I think we're all beginning to get used to using them. And I know that many spill response companies now have their own small drones with cameras, and as the drones are used more frequently, the price is coming down, but the capability is increasing. So drones are a fantastic tool in the spill responders toolkit. Now, the Express Pearl, we're going to touch on this, and I'm not going to steal Kate's thunder. But basically, this caught fire on the 20th of May, 2021. And despite attempts to extinguish it, the vessel burnt out by the 30th of May with salvors on board. The vessel hull broke when the towing started, but by that stage, it lost 1,486 containers. Now, 3 of those containers carried plastic pellets, each weighing approximately 26 tons. And the debris loss from the vessel was immense. It was highly polluting. It was very disruptive and has impacted not 60, but 150 kilometers, a bit over 150 kilometers of coastline. And its effects may continue for years. This is an early satellite. This is an early satellite image. This is a satellite image relatively similar to the date of the image I've just shown you. But you can see the resolution that you get from an orbital image, and overlaid onto this is some analysis from a modeling specialist. So as opposed to trying to talk about something I know absolutely nothing about, I'm going to hand over to Kate, who knows a lot more than I do, to talk you through monitoring. So I'm going to stop sharing and enable Kate to share. Thanks, Kate. That's great.
Yeah. Okay, so I currently work for a company called Oil Spill Response Limited. They're a global reaching company. So as it suggests, it's oil spills that we've been mainly involved with. Recently, we've been getting involved in other pollution and other things that may be lost overboard, such as containers, and starting to look into trying to get really involved within any of these plastic pollution working groups. So I'm sat on our internal working group, and also more recently become part of this wider working groups with other interested parties, such as the Spill with Market. So my background, the department I sit in, we do an awful lot of oil spill modelling for response, but also for preparedness work. So we do stochastic modelling, but we do this 2D sort of quick, fast response modelling to support echo of an incident. And it also trails into sensitivity mapping and then cross-referencing those sensitive areas with potential impact and all that kind of thing. So to wind back even further, sort of 14, 15 years ago, my undergraduate project at Plymouth University was actually looking at microplastic distribution in beach sediment. So hence my interest in getting involved and sitting with working groups and being a part of it. Anyway, we will take a look at where we are with modelling and trying to track plastic in a response situation. So computer modelling. We're well versed in the needs and requirements for computer modelling for a response for any spill scenario. It's one of those things that is a very powerful tool for us as responders, as a response organisation, to try and help identify and use our resources wisely. So, you know, it's a really good, essential predictive tool that can help us mostly with the speed of something, the direction in which it's moving, and when it comes to oil, we're quite well versed in the fates and behaviours of that potential oil, so it will help us understand what response techniques are available to us, what type of equipment we should be looking at, and the size and scale of the response that should be mounted in order to tackle that incident. So currently we've got there's a lot of movement on tracking plastic. It's mostly around particle modelling. So it's looking at particles on the sea surface and tracking what that looks like and how that will move on the sea surface. So it's the meta-ocean data that is being inputted that we're heavily relying on there to determine where those particles will be going. Existing oil spill modelling capability, we start talking about having a choice of oil that we can put into these computer models. So this comes from if we have a known oil that has been spilled, we can look in an analog oil library that we have, depending on which type of model or which software you use. There is usually a wide range that you can pick from. So everything from marine diesel up to a heavy fuel oil, because these have all been tested in laboratories for their behavior and fates in the marine environment, depending on wind speeds, weather, waves, etc. So we're really good at that, and we can pick an oil that matches the spilled oil, and we can have a really good confidence that that output is going to be something along the lines of where that oil is likely to go and how fast it's likely to get there. So there's work to be done on matching that with a plastic spill, because we're looking at particles now rather than a fluid. So let's move on to the next slide. So yeah, so the modeling for response outputs currently for the oil, we get a map output from our software, and just to describe the image on the left a little bit. So your the grey is your what we call the swept area, so that's where the oil has likely been, it's where it's tracked. The green along the coastline is the stretch of coastline that's likely to have been impacted by that oil, and you get various other pieces of data around using that map output. So visually, it's very quick to tell the reader where you are, what other information available you have there is places, likely towns, so you can start gauging population. The blue arrows are the current, so the bigger the arrow, the stronger the current, and you obviously have direction there. So it's a really good way of getting a responsible party information around what's happened and what they can do about it. The second part of that output is more database. So we produce a mass balance graph for oil. So that can tell us what is that oil likely to be doing based on its properties, which we determined by picking that matched analog oil. So we can start to look over, and we usually do this over a 5-day period because of confidence in data and confidence in forecast data, particularly about what's happening to that oil, where it is, whether it's being evaporated, whether it's ashore. So as you can see, in the first 24 hours with this incident, most of the oil has actually reached shore within that 24-hour period. So this is actually the modelling we produced for the Express Pearl incident, but this was for the HFO content on the vessel. So we are in a pretty good place with particle modelling for plastic to be able to produce where is it going and how fast. The trickier bit, and this is where there's been heaps of research and studies done, is more around the fate and behaviour of that plastic, and whether or not, and this is where I get interested, does any change in the fate and behaviour of that plastic actually impact where it's going and how fast it's going to get there? Because in terms of the response, that's really all we're looking to find, so that we can understand what that looks like in terms of the response. So oil v plastic in terms of response techniques, and certainly when it comes to the modelling part of that, we're really interested in that movement and how that movement is impacted by the current and the wind. So with oil, we know that oil moves 100% of the current and around 3% of the wind direction. We are expecting and find that that is true of plastic particles, but we know that with plastic particles sitting on the sea surface, the wind and all sorts of other factors especially in the near shore, such as wave movement, can potentially have different impacts on plastic particles rather than with oil because of it staying as a solid. So this is some of the things that the wider scientific community have already been investing heavily in conducting studies. So to move into one of those studies in particular, there's a Canadian study that has taken 4 different particle tracking models, and they have looked at their the background of how those software is set up, and it's basically a comparison study of these 4 particle models, and they have actually made some fairly sensible considerations here in terms of what to look for to determine really the robustness of these models as to whether they are suitable to use for plastic particle modeling. So really looking at things like that, whether there's any effect with physical transport process, whether there's any effect on the movement or behavior of those particles, if anything such as biofouling comes into play, and whether or not physical properties like the size and the diameter, or another question from my side is in terms of what if there's a variety of size plastic? What if that plastic isn't pristine nurdles? What if it's weathered? You know, does it make a difference in terms of what a response would look like? So that's all really sensible stuff, and this is a really good study, and I'm sure if anyone was interested, we could send a link to where you can find that if you wanted to read up on it any further. So some of the conclusions that they drew from this study was that actually all 4 of these particle tracking models were lacking in some areas when it came to specifically plastic particle modeling. So some of these areas that they found were not addressed properly was mostly around when plastic accumulates together in different ways. So the schematic there at the bottom was just something to try and help understand that plastics potentially adhering to each other. So this was something that was found by our guys, certainly on the beach when they were out in Sri Lanka cleaning up the nurdles, was that actually due to the heat that the plastic was sort of melting and smudging itself together, and was almost representing how you would find oiled tar balls on the beach there. So not only was it adhering to itself, it was also then taking along with it bits of sediment, bits of beach, you know, all sorts of other bits and bobs, that debris that you would find on the shoreline there. So that also then raises a whole host of other questions and problems to solve, which is around how do we recover this, and can we still use the same equipment, because equipment was designed so far to be looking at the individual nurdles, but it was around how could they then solve these problems. But in terms of modelling, this was something where this Canadian study felt that there was some lack of ability with the particle software modelling. But it's all stuff that's continuing to be looked into, and in terms of determining whether something is suitable for modelling in response, it's something that really my question is around: does it make that difference? Does it change what we need to know? Because this is something that's potentially happening at the sea, at the shoreline. If that's the case, then actually where is it going and how fast part of that model has already occurred. So it's really just bearing in mind all of those different questions and figuring out which ones are critical to us as a response organisation. So to go and look a little bit further into the Express Pearl case study, I know Mark has popped some figures up already, but this was just a slide that I borrowed from a friend who had delivered some more specific case study around this recently, but the video I thought was worth including. So really for ourselves, oil spill response, we were really interested in obviously the HFO that had been spilled, and then also the plastic pellets. So that was our main focus on, yes, the HFO, we're well versed in that, we know what we're doing. And really this response, it was really around transferable skills for our guys in terms of modelling, tracking, finding, cleaning up, and so on. So really, because the nature of this incident, we were fairly close to shore, and in the previous slide when I was looking at the mass balance, it shows that shoreline impact was occurring within reasonably around 24 hours of release. We were kind of finding nurdles on the beach already, so our assumption was that actually nurdles had kind of moved in the same way as what we would have expected the surface would from that moving output. I think over a longer distance, if something was further offshore, that's where we would start to really want to find a suitable solution for plastic particle modelling, just to see whether those differences in pollutant will make a change in the way that behaves in the sea surface. So moving into a bit of situational awareness, because the modelling feeds into this really, and it's part of that wider the software and common operating picture, which is my sort of remit within our company. So really, I think the best example is the top left image here. There's a few spots right at the top corner, and really it's one of those things where if you had a more remote area and reports of nurdles weren't coming in, but you had modelling that showed that there's a potential impact in that area, it allows you as the response manager to determine that, okay, most of the response effort is going to be down on the southwest coast there, but there is still need to possibly send one small task team further up north and to check that area, because without modelling, potentially that may get missed. So that's how and why we think having a capability to do plastic particle modelling and the response would be really useful in some situations. So yeah, so that's how that feeds into the situational awareness part. So this was just this is for oil, but this was just a video output of the modelling that we actually did for that incident. So it's a bit quick, it's 5 days worth over that short period, but it just shows you, let me see. Yeah. So it just gives you that swatch of where the oil may have been. And so what we really want to be able to do is try and do the same thing for plastic particles. Can we show where that plastic has been, where that plastic is heading, and you've got an area there where you might find plastic either on the sea surface or on the shoreline. So you can really focus that response effort. So just a few, yeah, so just a few concluding thoughts for this from myself really is, my next aim really is to try and find that solution to plastic modelling in a response, and really whether that can be widened to something that gives us something useful about the fates and behaviour of that plastic. And hopefully, although ours is a little bit focused on that response piece, if we find something that's pretty successful at doing that and it's fast, and we can do what we do now with oil, which is within a few hours get an output from something useful, some useful data, that might really have a wider positive impact on the environment in terms of cleanup, for an area that we may have had one of these spill situations. So yeah, that's all for me. But obviously any questions, please stick them in the chat, or I'm happy to talk about this subject and how to conclude if anyone's interested. Yeah, so I will switch sharing.
Thanks, Kate.
Come back to Mark.
That's great. I love that little model. I love that little picture. It's really cool.
It's not me.
You should have taken the credit. Nobody would have known. Well, I wouldn't have known. Yes. Anyway, the point I would make is that this was just 1,486 containers. What is sad is that in an average year, we're losing 1,383 containers. We're losing 1,383 containers off vessels. But in 2021, in the Pacific, there were over 3,000 container losses, and God knows how many of those contained hazardous cargo, and how many of those actually contain nurdles, which are being released, into the environment. And it is distressing that this trend continues, and it's all in a sense sad that even larger containers with even larger vessels with even more containers on them are now entering service, and are going to be subject to the same vagaries of weather and waves and rogue waves that these are, which have lost 3,000 containers in the Pacific alone. So I mean, this is a great opportunity for satellite tracking, because most of the containers that were lost in the Pacific, 30% of them floated for a month or more. And they represent obviously a danger to shipping, a danger to marine life. They're tragic for the environment. Yes, an action is beginning to be taken underneath IMO and all the rest of it. But actually, is it actually happening quickly enough? But this is a perfect environment for satellite tracking, so that the various Coast Guard agencies and people who monitor international shipping can ensure that vessels, including smaller vessels who could be severely impacted if they hit one of these containers, their movements they can avoid the location of where these containers are. It is a perfect solution for satellite tracking, and it enables the location of those containers to be passed back to the owner and in a sense the owner's insurer, and it would aid efforts to recover the container, or at least make sure that the thing has sunk. But of course, if it sinks, then whatever's in it is then going to tarnish the environment in which it's sat. And this is a picture of one Opus, which lost a lot of containers in the Pacific that year. Yeah. At least with containers, they're large enough for it to be tracked and to enable a prediction of the arrival point, which is essential for the responders so they can be there to meet it and actually make sure that the contents of it can be recovered and hopefully managed and disposed of appropriately. I'm not going to go on much more on modeling, but I'll just go back, because that's a slightly cool slide, which is also off Sri Lanka and some of the stuff that was produced there by NOAA. Anyway, citizen science. I don't think we should ever ignore the ability of citizens to be motivated to help when incidents occurs. But equally, we have a lot of motivated individuals. They're also consumers. They can also be influencers. And I'm sure that there's been many a beach clean where part of a subtle objective has been to make sure I capture a picture of me with lots of plastic recovered, so I can put it on my Instagram or whatever to show people of the type of person I am and what I'm interested in. But citizen science possesses many skills that, with a little bit of training, that can be harnessed. They are low or possibly no cost, and they tend to be, once motivated, persistent citizen scientists. And they take the role that they have very seriously. And the ability to observe the same piece of coastline day in, day out, and to report anything that is found is absolutely value to those who run models. And provided that provided that they are well trained, they have a proven benefit to projects in which they're involved. However, they must be well managed, and they must be motivated to believe in what they're doing is clearly worthwhile. It's better if they have goals so that they can be, which are clearly defined, and really the citizens who are giving of their time and their energy and their intellect and their enthusiasm can believe a deliverable. And they must be recognized in the output, which comes from research, which they might do. This is the big microplastic survey. It was sampling on lots and lots of beaches around the coastline. And all the data they were taking was then stuck into models, which told us what the plastic concentration is on a particular beach or whatever. It's really invaluable stuff. So I'm just having a look quickly. Right. So it is, but the benefit is when the science is accessible to all. And there's some really good stuff, which is the Plastic Soup Foundation, which is a non-profit based in Netherlands. They've developed guidelines for citizen science projects focused on plastic pollution. The information is readily available. The Marine Debris Tracker is a citizen science app developed by the University of Georgia and NOAA. It allows users to report sightings of marine debris, and the app includes protocols for data collection and submission. And the benefit of this is that you suddenly end up with thousands, possibly hundreds of thousands of observers who can then feed into the tracker, in other words, into the database, with generally quality controlled information, so that you are working with common data sets. But there are many other examples, and when in the paper that Kate and I have written, we reference those, and I would urge you to get it, have a look at the paper. This will be up in a couple of days' time. It's better that the science is accessible to all, because there's lots of people doing lots of good research everywhere. And the more data they have, the better informed the outcomes of that research will be. And I personally believe that the outputs from the citizens who are doing the work must be accessible to all. This is the debris tracker. It is a fantastic example of how data empowers collaboration and aids understanding. Note who's involved with it. Obviously, Morgan Stanley are providing the money, but it is fantastic that it is common. The key with research is that you want common data sets. The more that's shared, the more the analysis can be shared, and the data and the outcomes can be done. And it develops a common language through which people can be informed, which is of great value. Now, what we all want to know is, where has the pollution come from? Now, we know a lot of it is just coming through people being too lazy to dispose of waste properly. But there are key sources of pollution. And if we can identify the source of pollution, it will enable us to close off that source, and so that it becomes, we then go into preventing. If there is a spill from a factory, it's fantastic if if citizen science can inform us of that, so that basically the owners of that factory, which is leaking plastic nurdles out of it, can be dealt with by regulators. But it is really important that we find as much information about what is being leached as possible, the composition of it, the characteristics. Can we get it analyzed to identify exactly what plastic it is? Are there any traces within it? The analysis is key, because if we can tie all those things together, then prosecution becomes possible, and it then becomes a deterrent to offenders. Now, stakeholder engagement. The more people are involved and are involved in this journey, the better. A fantastic example is Operation Clean Sweep. Started in the United States. It was targeted very directly at producers, but it actually now works from producers to users, to really encourage them to behave properly and professionally. And it works. Operation Clean Sweep is working over in the United Kingdom, and it's working in, I think, 65 other countries. You've all seen things like the Million Mile Beach Clean, which is supported by, organised and coordinated by Surfers Against Sewage. You've seen Plastic Free July. You've seen park and river cleans go on. You've seen beach cleanups. you've seen when you go down to some beaches in Cornwall, there's an organization called cleansea.net who provide you with tools to pick up the plastic, bags to put it in, and bins in which you can dispose of the plastic bags. And they then ask you to put on their app what you've done, where you've collected it. And it's fantastic. Every time you do it, you feel you're engaged. But you're engaged in a larger mission, which is to try to reduce the amount of plastic going into the sea. And if we all do our bit, then that's great. So stakeholder engagement is about putting pressure on regulators, putting pressure on producers, but also putting pressure on consumers to ensure that they dispose of their waste properly. And the more involvement there is, the more coordinated that is, will lead to the more effective response. It's essential to use all the tools that there are to monitor, track, sample, analyze, and share data. Plastic pollution is a very emotive issue. We need to harness that. And as responders and those who are on this webinar, we're motivated about plastic pollution. We need to harness that emotion and engage all stakeholders, including those who are producers, and encourage best practice. And we need to collaborate together to achieve that. So that's all I've got to say. So now I've noticed while I've been talking, there's lots and lots of stuff in chat. Kate, is there, I think, let's have a look. Let's see. All right, okay. John Burton, do you think it will be possible using modeling techniques to aid source identification? Kate, do you want to comment on that, or have you already commented on it?
I did write a reply, but
what was your comment on it?
So we can do backtrack modeling. Certainly, it's not as there's not as much confidence in that. It's for various reasons that are probably beyond me. It's trickier to be accurate in doing that. So my comment really was it's kind of more of a general direction of where something may have come from. I mean, we can do it with oil. I know that particle modeling you can do backtrack modeling. I was chatting to some of the guys from Plymouth Uni, the Coastal Marine Environmental Research recently, and they've certainly done it once, maybe twice, but it's harder to do. So my example was say you'd had a spill, unidentified spill in the North Sea somewhere. We could look at some hindcast data for the previous week, and we could probably figure out roughly which oil rig or what field it had come from. But you could probably do that in tangent with sampling that oil, and I'm supposing that you may be able to figure something out if you took samples of plastic nurdles, potentially, that there would be some way of identifying one batch from another, possibly. I'm not sure on that, but if you can, that combined with a general direction is going to give you a better idea of being certain about where that's come from. In terms of would you be able to tell whether it's sat on the west coast of Wales and it's come from the Gulf of Mexico? I don't know. Is the honest answer, but it's certainly something that would be interesting to find out if it's possible to trace it at that far. But I think that will be down to sampling and identification of parts of possibility.
Great, thank you, Kate. Right, are there anybody got any other questions? Because if you have them, now's the time to ask. Yeah.
Hi, Mark. Can you hear me?
Yeah, who's that?
Sam Mills.
Hi, Sam.
Crawford, thanks for the talk. This is going to sound like a stupid question, probably. This is like completely out of my area of expertise. There was a point you made earlier about, was it 30% of containers float for a month or more or something?
Well, they did. Yes, they did. Yeah, they did.
How do you know that?
This was from data which NOAA tracked, because NOAA were tracking the containers.
This is satellite tracking, is it?
Yes, it was through satellite tracking which NOAA conducted. I mean, there was a big loss of the ship. One Opus lost all these containers, And because there were so many, NOAA were tasked with tracking them to inform seafarers where they were. And obviously, initially there were a lot, but it reduced over time, and they produced that data.
And then my second question, I suppose, is there any sort of legal responsibility or onus on anyone for attempting to recover those containers? Because presumably as soon as they sink or whatever happens to them, there's more potential for the contents to escape. Is there not some sort of sense in trying to recover those when they're floating about?
Well, the issue, yes, I think what happens is once they are passed from the owner of the container onto the ship, they then become the ship owner's responsibility to look after them, and they would then be covered by the ship owner's insurance. And Connor, if I'm wrong on this, I mean, do feel free to interject, but that's how I believe it works. So it becomes the insured party's responsibility, because they're the ones who are going to be compensating the owners of those container for the container itself, but more importantly, its contents. The issue is, how do you recover a container at sea? Well, you can, and there are vessels which can do it, but to me, it's not tried frequently enough, because there probably needs to be a greater incentive for people to go and recover these containers whilst they're floating, before their contents just pollute the ocean and treat the ocean as a dustbin. But I think it's something which I know there is a lot of discussion about this in IMO at the moment, we await their guidance and their wisdom to play a part in preventing them falling off. It doesn't really answer your question, but it's my best effort to.
Yeah, but if there was more legislation around responsible parties having ownership of containers and contents, it would certainly give us a lot more traction to.
My assumption is that the people who are insuring those containers are going to just pay for the loss of the contents of those containers and not necessarily give a monkeys about what happens to it afterwards. But I don't know if there's any sort of legislation in place to deal with that, but I imagine they just go, what was the value of that container, here's the money, sort of thing.
I think the part of the issue is that I mean, 3,000 containers sounds a lot falling in the Pacific, but even in that year, it was 0.001% of the total number of containers carried in that year had fallen off the vessel. So in terms of statistically, it's a very small proportion of containers falling off the vessel. But to those, in a sense, with an environmental mindset, each container that falls off is one too many, because particularly when it's carrying hazardous cargoes. But there's got to be an incentive for someone to go and collect them. And at the moment, I don't think there is. And that's probably why they just get left to sink and their contents to pollute further, and and if necessary, join the other 170 trillion pieces of plastic particles in the sea at the moment.
Mark.
Yeah.
I thought I would just give a bit of context for.
Is that Connor?
It is, yes. Hello.
Oh, Connor, great. Thank you very much. Yeah, please
Hello.
put some context, Connor. Yes.
Just on the containers, I can't really. Sorry if there's a background noise. It sounds a bit strange. I can't really comment on like deep sea containers being lost, but for the Express Pearl, there was a huge effort by the ship's insurer to recover the containers that fell off of the ship as a result of all of the explosions and whatnot. Both because of the environmental repercussions of those containers being on the seafloor, but also because of the sort of navigational risks those containers posed on lying on the seafloor in Colombo anchorage. So all of the containers in a very large area around the wreck were actually, a lot of effort was taken to recover them.
Good.
As I said, I can't really comment on containers out in the deep sea.
Yeah.
I think that's a different story. But for the Express Pearl, all of the debris around the wreck and in the vicinity were quite comprehensively cleaned up.
Yeah, I think the owners of the Express Pearl acted very quickly and very professionally in the way that they dealt with what was a most regrettable incident, which they weren't the cause. But it's they did seem to act very, very responsibly, conscious, of course, that they were very much in the public gaze. And I think that they should be an example to other ship owners who should try to recover as much debris as they can, which falls off their vessels. But of course, when it's in the open ocean, it's very expensive to get a salvage vessel to go out to recover a relatively small value that could be the contents of those containers. So anyway, yeah. But it is useful that it's great to know that satellites can track all this. And I know that in the MV Zoe, MSC Zoe, when it lost its containers, it was satellites with drones who were tracking where they went and predicting where they went. So I think it's good that capability now exists and it is being practiced, because the more we practice it, the more we learn. Certainly with plastic, there is a lot of research going on at the moment in universities and trying to improve these models. And I know that the work that Zoe is Kate, the work that Kate is doing within Oil Spill Response Limited, within their modeling team, is going to push this forward considerably. And I think that's really good for the industry and really good for modelers everywhere. Any other questions?
Just to add to that, Mark, we're just in discussion around, we've got a funded master's student at Plymouth University next year, I believe.
Yeah.
It'll either be something to do with plastic modelling or UAVs or something along those lines. And we've just started talking about the potential of possibly doing a jointly funded PhD in something too. So we will just try and do any number of things to do something towards that.
Yeah, I mean, there is a lot out there, and one thing that we're quite keen to, we're having a meeting, the group is having a meeting next week, really to start setting ourselves some goals for the next year, but particularly to look at how we can bring more universities within the group so that it's easier to share what they're doing, but also perhaps as we've done with Southampton University this year, which Josh Duran and John Burton have led on, they did a group design project. But what would be good is to also have that same, and we'll do another group design project with Southampton, I think, this coming year. But it would also be good to be pointing University of Portsmouth, University of Plymouth, in the same direction, so that they're all part of the family. But also we know what research they're doing and we can access that, because and then comment on it, because I think it's really good that we get bright young minds looking at problems that we've got now, because they can come at it with fresh eyes and with new enthusiasm, which is great. Anyone got any more questions before we slowly wrap up?
Yes, is there any effect of chlorine on the plastics if we were trying to do a degradation study, short-term or long-term? Is there any impact of concentrations of chlorine in the background?
Can anyone answer that? I'm probably above my pay grade, that one.
Yeah, I suppose, yes, potentially. This is part of that area, I think, where we've looked at some of these comparison studies, and the answer is, for modelling purposes, it's lacking. In actuality, I'm not sure. I haven't gone down that route of research to aid anything I'm looking into, but potentially. But then my question is, does it make a difference in terms of what happens to it, where it goes, and the response effort? So it doesn't really answer your question, but it's something to consider, certainly. Yes.
Yeah. I wonder, can I ask, Philip, do you mean chloride, as in the sea salt, or do you mean other organic chlorine-containing compounds in the sea? I wonder if you could...
Well, just for our purposes, we have, for treatment in our tank, we have to use sodium hypochlorite to treat our tank, and I'm just wondering if that affects the plastics for a study.
I'm not sure personally, but in terms of the chlorine content of the waste, for the waste repercussions, there's quite a lot of repercussions of how much chlorine is contained within whatever plastic is actually recovered, and whether it can be used in, for example, cement factories as a sort of energy recovery, or not, or landfill. There's a lot of repercussions there. But in terms of the modeling of the degradation, I've never heard anything.
No.
Not as far as I'm aware.
Thank you.
Sorry, it
Okay.
wasn't the best answer.
Okay, I mean, our next one in this series is on the 21st of June, assessment of ecological impacts of microplastic recovery. I'm working on that one at the moment, so input welcome, and we'll be discussing more on that next week. I'll also flag up that we're starting a 6-part marine webinar series, and we're going to start it with alternative fuels for shipping, risks and their implications for spill responders and salvers. And we have Marcus Russell from Oil Spill Response joining us, who's going to talk from the response side, and Oliver Timofey from Blue Tack Marine, who will talk from the salvage side. I think this is this is going to start it, but we're sort of going to continue this trend through the 6-part webinar series that we're doing. Obviously, we will break for the summer, but then it'd be rather like we had last year. We had a webinar series which ran throughout the year, and they were really good and provided by members generally of the association, and they should be quite thought-provoking. So I think that is all from me. What this will be, positive note to end on. There's lots of things happening within UNEP, and you've seen, I mean, within the group that are here, I guess you've seen what UNEP have been publishing. But also what is really, I'm going to Portsmouth University next week to talk about the enzyme project they're doing. I've been in touch with another university who've got a bacteria project where in both cases, the enzymes or the bacteria can munch the plastics. It depends on how effective that is, but you know, there's lots and lots of efforts going on to see what we can do to get rid of the plastic that we've got. But first, they need people to go and recover it, and with the 170 trillion particles that there are in the sea, and the vast amounts which are going into the sea. I mean, you know, it would be great if we can stop it going into the sea, but it'd be great if some governments give responders the responsibility to go and collect it, and that would be good, because that will keep us all in business. I'd like to thank particularly Kate. Thank you very much, Kate, for your presentation, and for Oil Spill Response for giving you the time and allowing you to work with us. Orbital EOS for the images and some words of advice from them, but also to the other members of the Plastic Pollution Working Group who are helping to put this series on, which is great. I will get an edit. I will be editing this presentation, which is recorded, in the aim of getting it up on the website on Friday or Monday, and we'll also publish the paper which Kate and I have written, which should put some flesh on the bone. I think that's how I put it. But thank you very much for joining us, and hopefully see you at another webinar shortly. Thanks very much indeed. Goodbye.